Okay, so today we're going to talk about random variables and what a random variable is. A random variable is a numeric value that describes an outcome that has some chance probability to it. So let's take two events and see which one's a random variable and which one's not. Let's say I have this first event that has some marbles. And let's say I take all these marbles and I put them in a hat, and then I take the marble out and I record what color it is. And I go, is that a random variable? And I would say no. Even though this thing has some chance to it, it's not a numeric value. Like a color is a qualitative kind of thing, and it's not quantitative, so it doesn't have a numeric value to it, so it's not a random variable. If I took a marble out and I counted how many blue marbles that I got, that would be a random event. But if I'm just recording color, it's not going to work. Let's say I have the second event. Let's say I roll two dice, and I take the sum of the two dice. And I go, is that a random variable? Well, yes. There's definitely a chance element. I don't know what dice are going to come up. And it's got a numeric value. So that would be a random variable. Let's see how these random variables now play a role. So there's two types of random variables. There would be a discrete, and there would be continuous. A discrete random variable has a fixed number of possible outcomes, or a fixed number of possibilities. One of those things would be a sum of two dice. There's only a certain number of outcomes that you get, which would be like 2, 3, 4, 5, all the way up to 12. That's it. You can't get any other outcomes than that. Another thing that would be a fixed number of outcomes is flipping a coin 4 times and recording the number of heads. You could only get 0, 1, 2, 3, or 4. Another thing that would be that way would be the number of people in a household. The only thing you could get would be like 0, 1, 2, 3, and we could keep going up, but there's only so many people you could actually fit inside a house. Things that would be continuous with things that would make more sense to put in intervals, like weights of people at Homestead. There's so many people at Homestead that have so many different weights that it really wouldn't make sense to say, well, we're going to go all the way from 20 or from 50 pounds, maybe that's our lowest, all the way up to, I don't even know how much people like what would be the max weight. But when you're doing this and you're thinking all the different weights that you could possibly get, like you could even get decimals here, like somebody could be like 100.3 repeating pounds if you have a scale accurate enough to measure some of these things. So this makes more sense to put in an interval. Same thing with heights of people. Even though like most people are going to fall between a certain range, when you start talking about like somebody could be 5, 8 1/4 inch, like you wouldn't really want to go through and figure out every single possible outcome there. So it would make more sense to put in an interval, and that would be a continuous event. So those are the two types. Like we could have something that would be discrete, or we could have something that could be continuous. Let's look at how some of these problems would go. So if we look at this, a lot of times we're going to start out with looking at a given probability distribution, and this would be a discrete event. And we would know this would be a discrete event because it has a finite number of outcomes, like 2, 3, 4, 5, 6, or 7 plus. So that's the number of outcomes or discrete possibilities that we have. And they said let X represent the number of people in a household. So the first thing that we're going to do is we're going to actually see if this is a true probability distribution. And you know if something's a true probability distribution is if when we add up all of these events, if they equal 1 or 100%. So we're just going to do that real quick just to check. So 8 plus 0.209 plus 0.092 plus 0.032 plus 0.018. and we get it to 0.99999, so it probably is exactly 1. There's probably some kind of rounding, so if we get close to 1, like that, it is a probability distribution. So we're going to deal with this, and we're going to do a couple things. So the first thing that we're going to do is we're actually going to see what the probability distribution looks like by making a histogram. So we're going to make a histogram. See what that looks like. Okay, so we're going to kind of rough sketch this. This is going to be a real rough sketch. But again, you're just going to kind of make your intervals. We'll make this a midpoint histogram. So I go out, and this would be, let's call this 2, 3, 4, 5, 6, and that be 7 plus. Okay, and let's make these different colors. So 2 is going to go up to a little bit over 4.2. And this would actually probably fill in all the space. This one goes to here. This one goes a little bit above 2. 5 doesn't quite go up to 1. This gets even smaller, and this gets smaller. And as you can see, this histogram would be left skewed because the tail, or right skewed because the tail is on the right side. So this is going to be a right skewed histogram. If you remember from the first chapter. So we got a right skewed histogram as it kind of slopes down through all the points, and so we get a good idea of what the probability distribution looks like. And so that's how a histogram can be helpful. Now we're going to figure out some of these probabilities, and it's actually pretty easy to figure out these things once you're given a table. So I just removed the histogram to give me some room, but here again, if you need it over here, it was kind of like this right skew. And again, if they ask you to describe, that's what they really want from this, is they want you to say like what kind of skew you have, all the kind of spread and shape that we used in the first couple chapters. So now we're going to figure out some of this piece of information. So they could give us a problem that would be like this. So what's the probability, if I could write, of my sample space being between 2 and 6 number of people? Well, if I was doing that, that would include my 0.42, my 0.228, my 0.209, and my 0.092. It would not include these two because those would be 6, and it has to be strictly less than 6, and 7 would be greater. So we would just add those things up together and see what we got. And we would find that the probability that it would be between 2 and 6 people in a household would be about 95%. Okay? We could do another kind of probability. So our probability could be this time that, let's say, we were strictly equal to 2. If we were strictly equal to 2 this time, then it would just be 0.42. One last one that we could do is we could be strictly greater than 6. If my probability was greater than 6, that would include only my 7 right here, because that's the only thing that's bigger than 6. So it would just be 0.018. Okay, so we use these probabilities to decide what range everything falls in between, and once we find the range that it falls in between, we write what those probabilities would be. And that's how we would kind of use it. So those are the big topics of today: knowing how to read stuff from a table, being able to make a histogram to be able to tell what the different skew is, being able to tell whether something is discrete or continuous, and then being able to tell what kind of random variable. Sometimes you're going to be given this table, and sometimes you're going to have to create this table. If you need help creating any of the probability distributions, please ask. And please ask any questions on any of the different events today.